What's up, guys? We're back again for today. My audio is kind of bad, so I'm gonna try to scream and shout. So you might hear some background noise because I'm using my PC audio. And for today, we're gonna continue solving where we left up in the engineering economics for the FE. Um, I believe we're in question 9. So let's go. And question 9, we have a computer with a useful life of 13 years has the following cost and interest. So, oh, why is this not working? Sorry, I don't know what's wrong today with all my stuff. Yeah, not working. This is weird. Okay. Maybe this is why the audio wasn't working. Okay. So we have question 9. And question 9 said a computer with a useful life of 13 years. So the lifespan time is 13 years. The initial cost is 15,500. Salvage value 3,100. Um, from years 1 to 8, the annual maintenance is 275, and 9 to 13, the annual maintenance is 425. The interest rate is 16%. They say we should find the equivalent uniform cost EUAC of the computer. So this is tricky because they gave us two different costs for the annual maintenance. So the for us to get the equivalent annual the EUAC, we have to find the future annual maintenance for the first eight for the first from year 1 to 8. We have to find it for 13 years, and we have to find from year 9 to 13, which is 5 with 425. So how are we going to do this? Go to our engineering economics. Remember, we're not dealing with costs here. Remember, in this problem, we're trying to see the future maintenance given the cost. Okay, we have the cost of maintenance and we're trying to get the future maintenance. So this is kind of a bit tricky from all we have been doing. Okay, all I've been doing before. So for this, we're going to use the uniform series compound amount. We're going to use the uniform series compound amount to work on these two annual maintenance. So we're going to have F or 275 because we're trying to find the future. It's going to give us A, F over A, 6%. That's our interest on 13. So I've already solved this. Remember how we can solve this? Remember we can either use this table, or we can use the formula. Let me see if the 6% is in the table. Let's say 6% is in the table. 6% is in the table. Okay, so we're going to use that. So we're looking for f of a, f divided by a. Okay, and the year is what, 13 years, f divided by a, 13 years. So that gives us a constant of 18821. So this is going to give us, remember our first maintenance is 275 multiplied by 18.8821. So we're going to do maintenance for F150. When we solve for this is going to give us 5,192.60. So maintenance for F50 is going to be F over A, 6% and 13. Okay. And when we solve for that, we're going to have 150. This is in dollars. Multiplied by F over A, 6%. Okay. Sorry, this is not meant to be 150. This is meant to be 5. The reason why this is 5 is because it's from year 9 to 13. And from year 9 to 13 is 5 years. Okay? So from year 9 to 13 is five years. So that's why this is 5. And the reason why this is 150 because we're subtracting 425 minus 275. That's how we got this 150. So we're finding the difference between 9 and 13 and 425 minus 275. And that's how we ended up with this. So when we're doing the F over A, we're going to do F over A of 5. So that's going to give us this multiplied by this multiplied by 5.6371. So this is going to give us 845.60. Then the future maintenance, we're going to add both stuff. Maintenance, I don't know why I always spell this wrong. It's going to give us 5192.6 plus 845.6. It's giving us 6038. Okay. Now we have this future maintenance. We are not going to convert this future maintenance value to the maintenance cost. Okay. So if we're converting the future to the maintenance cost, that means we're going to use what? We're going to come back again. We're going to come back again and use this formula. Okay. So we're going to have A maintenance is equals to F maintenance divided by A divided by F, 6%, 13. Use the same approach. We're going to have, this is going to be 6038 multiplied by 0.0530. So this is equals to 320. So this is our maintenance. This is going to be our maintenance cost. Let me see if my audio is going to work this time. I don't know what was wrong. It hasn't been working. See guys, I don't know what's wrong. Let me check OBS Studio if my OBS Studio looks like it's fine, but I don't know why it's not working. So sorry about that, guys. Let me check online if I can get a different mic. I think that might be the best route. Microphone. What? The mics are really man, these are expensive now. Okay, I'll try and see if I can get a mic just for you guys. Tired of this. Let's keep going. Now we have the maintenance. Now we just want to calculate the EUAC. The EUAC, now we have the maintenance. The A initial plus the A maintenance Do we have an operating stuff for the pump? Let me see. Uh, Man, we don't have maintenance, so we just minus it by the A salvage value because salvage. So when we have that, we're gonna have what's wrong? Something is wrong. So we're gonna have 5,500 multiplied by A divided by P, 6%, 13, plus we have the maintenance as 320. We minus it by the salvage value, which is 3,100, and we have. So when we do all this math and use the table, we're gonna be left with 777, which is B. Okay? I'm gonna see if I can finish this engineering economics today. I don't know what's wrong with my PC. It's just acting different. I'm gonna see if I can finish this engineering economics today and go straight to the next topic tomorrow, and we keep going. I'm gonna skip two chapters here because I don't think they're necessary for the FE, but we'll keep going. Okay, let's keep going. Let's keep going. So, question 10. So, I was just reading something on what's wrong with this. Oh, what's happening? Okay. Give me a sec, guys. Give me a sec. We do it live, man. We do it live. I think there's something wrong with one of my adapters. I'm just gonna take it off. Yeah, I think there's something wrong with the adapter. I'm gonna mute myself for a while. Let me see if I can fix my audio real quick. Let me see. Okay, guys, I can fix it, but I fix the what's it called? I can't fix it, but I can fix the pen, so we're good. So question 10, let me pull up my notes real quick. So question 10, it said the initial cost of a computer. So the initial cost of the computer is 1500. The annual maintenance of the computer is 500 per year. The interest rate is 4%. They said most nearly what is the present worth of all expenditure. So we're looking at we're looking for the P of the initial cost, the P for the maintenance. So easy, if we want to get the P for the maintenance, it's gonna be easy, it's gonna be A divided by I. Remember our first formula. So we have 500 over 0.04, which is 1250. The initial is 1500. So all we're going to do is we're going to add P total equals to P maintenance plus P initial. So it's going to be 1250 plus 1500, which is 1400. So that is going to give us C. C. Remember this formula? We use this formula in our first question. So we use the right here where we're trying to get the interest rate. We also use this formula again. It wasn't here. We use this formula twice. We also use it over um, I know we use it twice to find the capitalized something. Okay. But that's how we solve it. Okay, that's how we solve it. That's how we solve that question. Let's move over to the next question. Question 11. We do it live, guys. I'm gonna try solve all the questions today, except question 20, because I don't know how to solve that. We have a computer with a useful life, so the lifespan is 12 years. It has an initial cost of 2300, a salvage value of 350. The interest rate is 6%. Let's say using the straight line method, what is most nearly the total depreciation of the computer? Boom. Using the straight line method, what's the total depreciation of the computer? We go to our engineering economics and we're going to have this straight line method depreciation, which is d of j is equal to c minus s of n over n. So we have this, and is this, our initial cost is this 2300. Our s is our salvage value, which is 350, and N is 12 years. So D of J, the depreciation factor is going to be 2300 minus 350 divided by 12, which is going to give us 162.5. And now they asked us, what is the total depreciation for 5 years? If we want to find the total depreciation of 5 years, all we're going to do is that we're going to multiply D of J multiplied by the time, which is 5 years. So we're going to have 162.5 multiplied by 5, which is going to give us 812.50, which is very similar to 810. So our answer is B. This is the same as markers, like what we used before. So this is going to be very easy. Remember when we had this question right here that involved markers depreciation? Um, what question was it? I think it was question 6. Which question was it that we had markers? Yeah, question 6. That we had the initial cost, we have the interest, we had the annual maintenance. They say using markers recovery depreciation, assuming 7 years recovery. When we know the 7 years, we'll go get the markers value when we know the 7 years recovery. And we'll get the markers factor and we're going to multiply by the cost. Okay? Because here they say what's the most depreciation, assuming recovery, what's the most depreciation allowance for cable for the first year. We know the initial cost. We get the markers using the recovery formula. The annual maintenance cost is this, but they were not asking, they're asking us for the depreciation. What's the depreciation of the cable alone? So we just multiply it. So that's how we solved it the last time with markers cost. This time it's gonna be very, very, this question right here. Let me see the question. So I'm just looking at question 3 again. Okay, this was the capitalized cost stuff that we used, that we had to use this formula again for capitalized cost. So that we had to find the cost of the pump. We added cost of the pump. We added the annual maintenance plus the cost of the pump, because we're looking for the capitalized cost for running and maintaining. And we'll just use that formula. So sometimes this can be tricky. Uh, so I was just trying to refresh my brain again. So one question 12, I believe. And equation 12, they say a computer with useful lifespan a computer with a useful lifespan. So the time is 12 years. They said it has an initial cost, 3200, salvage value of 100. The interest is 10%. And they say using the markers recovery method, depreciation and the 10 years recovery period, what mostly is the book value. So they're asking us for the book value BV. And the book value is right here, which is the initial cost multiplied by E of dj, which is the depreciation depreciation of it. And for us to get the dj, we're going to use the macro system. So we're looking for the depreciation of 3200, because they say what's the book value after the second year. So we're looking for depreciation of 3200 in the first day and in the second year, because they said what's the most book value of the computer after the second year. So they're asking for only the book value of the computer. Okay. Sorry, my audio is bad, so I'm gonna have to end the stream earlier. So how are we gonna do this? We're gonna ignore the salvage value, and we're gonna have the A1 and 2. We're gonna have the factor, which is the recovery, Marcus recovery, and we're gonna have DJ. So this is a 10-year recovery period. So we go to Marcus 10 years recovery. Our factor is 0.10 in percent and 0.18. So we're going to have 0.1 times 3,200, which are our part, and 0.18 multiplied by 3,200. When we do this, we're going to add it and we're going to have 896. So our BV is equals to the initial 3,200 minus 896. And this is going to give us 2304, which is going to be C. So that's how we solve for that. Mm, mm, mm. That's how we solve for that. I'm going to end the stream right now because I don't like the way the audio is doing. So see you guys tomorrow.